Hello and welcome back. And for our last speaker today, we have Luke Holmquist. Luke is a senior software engineer at Red Hat, where he helps lead the cloud and enterprise group for the Node.js runtime team. Closing the conference on a high note, I give you Luke Holmquist and Serverless with a chance of CloudEvents.
Hello, thanks, Katie. All right, just looking at that picture from my slide, I realized that's probably like 15 years old. So this is what I look like now. Right, yeah. So thanks everybody for coming to my talk. It's the last one of the day, I believe, before the closing ceremonies. Serverless with a chance of CloudEvents. I just want to say that I'm pretty excited to be back to NodeConf, even though it is remote. This is my third year now, I think. It's kind of been always one of my favorites to attend and stuff, and I've always met a lot of kind of great people at the Red Hat booth when I'm doing booth duty, and I just want to give a shout out to the person that I met on the bus last year on the way down after they asked me to watch the luggage real quick. So shout out to that person if you're still watching. All right, anyway, let's just get started, I guess. Right, yeah. So just a little introduction here. My name is Luke Holmquist, senior software engineer at Red Hat. My main focus is on the NodeShift project, and that project kind of aims to make Node.js developer kind of applications work better on OpenShift and Kubernetes. I'm also a maintainer of the CloudEvents JS SDK, which we're going to talk about in a few minutes. On Twitter, you can find me at Sienna Luke. Also a huge Fish fan, the band Fish. And just another fun fact, I'm also the current title holder of a Star Wars trivia contest at my local library. So I don't have a trophy or anything, but it's one of my accolades, I guess. And for those wondering, the winning question was, what was the number on Princess Leia's cell in the original Star Wars? So if you stick around towards the end of the presentation, I will give you the answer to that, unless you Google it now. So whatever. All right, so let's just get in here too. And since we're all remote, I just kind of wanted to show you where I was in the world. So I'm located in upstate New York. If you're not a New Yorker, this picture probably will make 0 sense. But if you are watching this and you are from New York, you guys know what I'm talking about. So anyway. All right, anyway, so yeah, let's just jump right in here. So as the title said, we're going to talk about CloudEvents. Well, what are these things called CloudEvents, right? So CloudEvents is a specification for describing event data in a common way. CloudEvents seek to dramatically simplify event declaration and delivery across different services and platforms, especially when we're talking about events that could be triggering serverless functions and stuff. So, but before we kind of get into the details of CloudEvents and the spec and what they are, just kind of do a little history lesson and kind of go back. Let's take in our DeLorean here, or whatever time machine you like to use. A little trip back in time, like 47 years ago, it feels like, to the year 2017. So back then, today people are always talking about serverless, and it's a huge thing, and they're talking about serverless functions and everything. But back then, 2017, it was a relatively new space. So it was just sort of starting to become meme-worthy back then. So the Cloud Native Computing Foundation, or the CNCF, which many folks probably have heard of, they have just a couple projects that they work on, as this slide shows. They created a serverless working group to see if was there anything that maybe the CNCF should get involved in the serverless space. Just check it out, see what was there, and see what's what. So what they found there was that there was many serverless solutions, a lot of these different platforms and stuff, but there was no real interoperability between any of these platforms. So you couldn't just move, if you had functions running as a service or something, you couldn't just move one function from one platform to another. And that was kind of a real pain for the developers and stuff. And that problem, really, there was a real good way of tackling that problem, because in order to do that, you'd have to include input from multiple vendors, and all those vendors are possibly have many differing points of view. So things can get political really quick. So they decided, is there some sort of low-hanging fruit that they could do? Was there some sort of common theme between the solutions that they could use as a starting point? And what they found there was that a lot of the workloads in serverless were all event-based, right? So events are sent from some service or something. They're usually routed, probably some middleware, possibly more than once. They can take multiple hops and that kind of stuff. And it's possibly over many different protocols as well. And it's the job of these middlewares to route the events, to the appropriate places. And those things, they don't really care what the message is that you're sending, right? It doesn't really care about this. Logic. It needs to know enough information to route to those things properly. Like, should it go to an HTTP protocol, or should it go through NATs or something like that? So they thought, maybe this is a good space. This eventing space is maybe the low-hanging fruit that they could start and look to see if maybe there's some sort of commonality between the events from these different platforms. So the goal here, it wasn't to create a new, not another event format, because those things have been tried before with little to no success here. But really, it was to define common metadata for the events and where this metadata should appear in the message that is being sent. So really, it's a pretty simple spec. It's common metadata, it's a common location, just enough to help with the routing. So very simple spec with very simple goals and stuff. So in December of 2017, CloudEvents is born. In October of 2019, so just about a year ago, it became a CNCF incubator project, and version 1 of the spec was released. So while this spec actually discusses a lot of different transfer protocols like MQTT, HTTP, Kafka, NATs, as well as some different coding way you can encode events, like using JSON or Avro and stuff like that. In the next few slides that we go through, I'm going to be looking specifically at how Cloud Events relate to HTTP, and also in how they're encoded in JSON. So just kind of as an FYI, as we go through these next few slides, it's going to be very HTTP based, JSON based. So let's take a quick look at what some of this metadata is that they came up with. And you'll notice that there's some asterisks on some of these, and on 4, and those are what are the required fields. So all events have to have these ones with the asterisks on them. So if we take a look at these, so we have a type, and this type is really defining what kind of event, what type of event this is. It could be a create event, a delete event, some other type that somebody wants to do. And then also the spec version is also required. So in this case, it would be version 1.0 or something like that. Source here is where the event came from. And if you wanted to make things a little bit more granular on where things came from, then that's where the subject field would come into play. And then you also have an ID, which I think is somewhat self-explanatory, but it's it's just a unique identifier. It's useful for deduping. So if you have multiple events being sent, or the same event being sent multiple times, and you can kind of see that if you've already gotten it, and do some deduplication there. There's a time field just saying when the event was set. Also data content type and schema. If you want to change the specifically say this is the kind of data that we're sending, and if you want to validate your event and your data based on some sort of schema and that kind of thing. But those ones aren't required here. There's also some extensions that a user can define if they need a little bit more metadata that's not in the spec. They can define some extensions, but it's still defined in the same place that these other pieces of metadata are. And if there are extensions that people and other users are using consistently, and there's a common thread between them, then at some point maybe those will become part of the specification. I also put adapters here. Now, adapters isn't really part of the spec here, but I just wanted to kind of call it out because in our spec repo, there's docs around these adapters for some popular platforms like S3, GitLab, and GitHub. So for example, GitHub, the webhooks for GitHub, they don't actually send Cloud Events yet. So the team has worked to define some metadata in these webhooks saying, hey, if you have these things, they map to these fields in a Cloud Event. So if you wanted to convert a GitHub webhook to a Cloud Event, you could use these documents and transform them, and you can transform it in a predictable way. Right. So talking about the metadata formats, there's 2 at the moment that you can choose from. One is called binary, and this is sort of the preferred way that we think. And the reason why is because it's sort of additive. So basically, in the binary format, it only adds header. Oh, and we're talking about HTTP here. So it really only adds headers to the HTTP request. So not really changing the request too much. So if you have a request that's being sent to some middleware, for instance, and that middleware doesn't know about Cloud Events, it's not going to break anything. It's still going to go through. It just will ignore those headers. And then, at some point in the future, if that middleware gets updated to know about Cloud Events, then things will start working again. Or not working again. They'll just start working with Cloud Events as well, because now it knows about it. And the other one is structured. So for those folks who, they haven't done anything yet, they don't have any defined format currently, and they're looking for just some guidance or something on the way things should be structured. We have this other structured format. All right, so let's take just a kind of a quick look at maybe a raw HTTP request here, real quick. So here we have just an HTTP request, post request. It should be somewhat familiar to folks if they've ever kind of looked at requests in like the Chrome debugger or anything like that. Here, we're sending a content type of application JSON, and the body payload is we have an action called create thing and an item 2187 here. So we can actually add. So if we add in and make it a Cloud Event message, all we have to do is add in these headers. And for binary here, the headers have the CE- prefix. So here we have the four pieces of metadata that are required here. So we have our spec version, we have our type here. It's coming from this nodeshift.create, or it's a create type from this nodeshift org or wherever it is. The source is coming from this nodeshift.dev site, and then an ID. Just, it's in real life it would be randomly generated, but here we're using just 1, 2, 3, 4, 5, 6 as an example. And then just to show what the structure would look like here, so the headers are very similar except for the content type here. We're actually using the special application Cloud Events plus JSON content type, but instead of putting the metadata into the headers here, we're putting it into the request body. So we're just adding those fields that were from the binary to the request body, and the data is now in the data property, kind of one level down inside that message. And if you are an astute observer, the number that was in the item thing is actually the answer to the Star Wars question that I posed earlier. So yeah, also it's the Stormtrooper designation for Finn in Force Awakens, in case anybody else was as nerdy as I am with that. So anyway, so these are kind of what the formats look like in kind of a raw HTTP setting here. But we don't really use this way, right? We use SDKs and stuff. So here we'll check out some of what the SDK is all about. So the spec defines some guidelines for what an SDK has to do, right? So it has to compose an event. To be able to compose an event, it has to be able to take that event and based on some sort of transport method, we have to encode it correctly, and so we can send it. And then any events that come in, we need to be able to decode those into event based on HTTP or those different transport methods and stuff like that. And in just a couple of minutes, we'll see kind of examples of what these are. And just as a kind of an FYI for folks there who I know this is a NodeConf, so we're going to look at the JavaScript SDK, but we had in all the kind of, I don't want to say major languages, but in all the sort of the usual suspects of languages, there are SDKs. They all vary with the degrees of maturity, but those basic principles we just kind of talked about are all in there. And stuff. So yeah, so let's take a look at the JavaScript one because we are at a NodeConf. Right, so very easy to install, npm install Cloud Events. It has gone through some major revisions in the last 6 months. It was rewritten totally in TypeScript over the last few months. We're currently on version 3.2.0. So what can this SDK do, right? Like we said before, it can represent a Cloud Event in memory. It can serialize and deserialize Cloud Events in these different formats, and it can send and receive Cloud Events, these different protocols and that thing. And at the moment for the JavaScript one, only HTTP is supported, but we're in talks right now to support. I think MQTT might be the one that's up next. And then next week, I think we're going to release the next major version, which is 4.0. This removes a lot of kind of the old ways of the way you would receive and you would emit events. But the examples that I'm going to show have all the new APIs, and those are actually currently available in the 3.2.0 release. So if you are interested in using it now, you don't actually have to wait till the 4.0 release to come out. All right, so okay, let's see how we we create a cloud event here. And I realized I made the animation a little slow. So anyway, yeah, right. So you require just like a normal thing. You require the cloud events. Here we're going to use the cloud event class. Here we, in order to create a cloud event, we just give it some options. Here we're putting the type and the source in, and giving it some data. And then when we console, we can console log out. There's a to JSON method on the cloud event here, so it'll print out in the correct format over on the side. Because I think we hide some of the data fields, so we can't just do a regular console log of just that CE variable. So you could see here what we have the ID, which gets added. That will be a UID that gets generated. Here we have the type and the source, which is what we passed in. The spec version will get populated by default because there is really only one version. The time will get populated by default based on when you create it, and the data gets added. So really, a cloud event, the event itself is really only an object, and you could just create that event manually if you wanted to, but then you'd have to worry about the formatting and all that stuff. So using kind of this constructor is a good way to do that. All right. So now if you've created a cloud event and you want to add maybe an extension to it. So whenever we create a cloud event, they're always immutable. So we freeze them after they're created. So if you wanted to add anything to it, like an extension in this case, there's a clone with method. So you just say, I want to clone it with this particular property and this value. And then that will return a new cloud event for you. And if we log that out, we can see that, and I've kind of bolded, maybe, I don't know, hopefully it'll come through, that the extension 1 here was added to the cloud event. So now we've created a cloud event. Let's talk a little bit about how we actually send them out and emit them. So here we're just gonna build upon the previous slide, just so we don't have to list all those options when we're creating the cloud event here. So in this case, we're requiring here the cloud event class, but then we're also requiring this HTTP object. Now we create our cloud event like normal, and then to put it in the binary format, we just say this HTTP.binary method, and we give it the cloud event, and that gives us our message. So when we log that message out, here we can see that it gives us these headers and the body, in the correct formats. And just as kind of just for completeness here is what it would look like. What it would look like for the structured mode. So it's the same kind of thing. It's just .structured instead of .binary for the call. And here, it creates the header of the application cloud events plus JSON, and also gives us the body because that's all the metadata is stored in the body of the request here. Now we haven't actually sent, at this point, haven't actually sent any messages yet with cloud events. So we're going to use an Axios or a library like Axios here. So again, building on the previous slide, we're going to take that message. We're going to, for the data, we're going to say, okay, we want the message body and we want the message headers, and put it in there. This URL just points to some random localhost cloud eventy endpoint, and it's a post method here. And then we're going to, since it's Axios, it returns a promise, so we can do that then, or we can do an async await if we want to. We'll log out the response data, and we're going to pretend that it returns, this object that has key and event received. If anybody has ever used the previous versions of the SDK, they might know that we would emit and we would have Axios built in, and it would do all of that for you. But what we realized when we were talking about protocols that we want to add next, we realized that it was going to start to clutter up the module itself. So, MQTT is one of the things we wanted to add, and that module is very, very large. The MQTT protocol library is very, very large. So we didn't want to kind of bloat the module if you were going to only use HTTP. So we figured the module should really only be the thing that formats your message and formats your events, and then you can use any transfer protocol you want, library, to then send those things out. So if you wanted to use requests, for instance, even though it's deprecated, you could use that instead of Axios. So just a little sort of tangent there on kind of why that was like that. Right. So like I said, this sends out the message. So now we can actually see what this receiver would look like here. So here we're using just Express to create create an API. I'm kind of doing glossing over a few things. Like I'm not I haven't added the body parser because you would need that to get the request, the body for the request. So I'm leaving a few things out here just for in terms of slide real estate. But anyway, so the request would come in. You would use this HTTP method, this toEvent method, with the give it the request headers, give it the request body, and then when we log that out, that should show us that was, yes, that's the event that we saw previously that we had just sent. And then here we're just sending out that event received key, just so we have a fully flowing example here. All right. So yeah, so I think we're about at 20 minutes here. So yeah, so if you want to, and it's just kind of a quick overview. If you want to learn more, there's a whole bunch of links here. You can check out the CloudEvents.io website. I have the GitHub org for the CloudEvents. There's the spec repo, the specific JS repo here. If you want to get involved, we have weekly calls on Thursday at 12 p.m. Eastern Standard Time, New York time, I guess, on Slack. There's a Slack channel here. And then right after those calls, every 2 weeks or so, we have the actual SDK call. So if there's anything specific to the SDK, we'll have those calls as well. I also put a link here to this CloudEvents Async API talk, which a lot of this kind of the background information that I talked about was based on. So if you want to have a little bit more in depth on the background information, that is probably a good video to watch. And just a link to the code example, actual really functioning code example that I kind of just showed those snippets of there. And then also a link to the NodeShift project if you're interested in what we're doing over there as well, just as a shameless plug. Also, if you're in the US, make sure to go vote today. But with that was the end of the talk. And I think we have probably a little bit of time for questions.
Okay. Thanks, Luke. That was excellent. I've got a couple of questions for you, but if anybody else wants to add any questions, please use Slido. Add your questions in there and we can go through them as they come in. So to start off, could you tell me what projects are using CloudEvents today?
Right, yeah. So Knative is probably one of the bigger ones that have settled on using CloudEvents from the very start. Also on the website, and I should probably have the website up, but there's a whole list of other projects that are using it as well. So it's quite a lot of a good amount at the moment, even though for such a young spec, there's a lot of interest so far, which is very cool.
Cool. And are any vendors supporting the CloudEvents effort?
Right. Yeah. So Red Hat. That's where I'm from. IBM, Microsoft, Google. So kind of all those the big names in the serverless space. They're all part of. We're all part of drafting the spec, and they all have interests and are participating in creating all these SDKs and stuff. Yeah. So yeah. So we have a good community so far around it.
Excellent. There are no more questions, so I am going to leave it at that. Thank you ever so much, Luke. It was a fun. Oh, hang on. One coming in at the last minute.
Another question.
Yeah.
All right.
What would so Nagitor, what would be the easiest way to try out for a toy project?
I would go and check out the. If you're interested in the JavaScript SDK, I would go and check out our GitHub repo. There's some examples in the repo that shows some TypeScript examples as well as just regular Node examples there. Yeah, and you don't need any kind of serverless platform. If you want to try it just locally, you can run all those examples locally. There's even a really cool kind of weather app that uses some WebSockets as well, where it sends the events back and forth, and you can put in your zip code or whatever, and it'll go to a weather service and give you the weather. So that's sort of more of a real life example there. Yep.
Nice, thank you. Okay, just giving it a second in case somebody else is typing away. Nope, nothing coming up. Thank you, Luke. That was a great conference closing talk.